Hi everyone, let's have a go through the week 11 work, which is solving equations. Up to now we've simplified equations and so on, and we had this equals that and all that as we got it down, but we didn't start with an equal sign in there. Here we're starting with an equal sign, so equations have something equals something, and we've got to get it down, and our aim always is to find the variable. There's one set of variables, or maybe there's two sets of variables. By variables I mean the letter. You know, like this simple example says x plus 10 equals 15. X is the variable that we don't know what it is, but we're given enough information that we can find out. We can see just by observation that what gets added to 10 to give 15, that x must be a 5. But we're also going to look at this balance method, just general equation solving, a technique that works all the time to methodically solve equations. So as soon as I have even an equation as simple as this, x plus 10 equals 15, I know I want an answer of x equals something, or the x by itself. So I look at the left-hand side of the equation and I say, look, I don't want this plus 10 here. I think, well, what's the opposite of plus 10? It's minus 10. So I can subtract a 10 off the left-hand side to get rid of it. But if I want to keep this balance, if left equals right, I can walk up to the left and take 10 off it if I want, but I'd better walk up to the right and take 10 off it as well. Same as scales. If I had scales that were balanced and I took 10 grams off the left and took 10 grams off the right, they'll still be balanced. So the plus 10 got taken away by the minus 10, so the left is now just an x. On the right is 15 minus 10, which is a 5. So that's just the methodical thing we do to try and get that x by itself. We do the opposite of what we've got there to remove it. So we'll get more into that soon. Note that these things I wrote here, they're notes to myself. I'm explaining what I'm doing. I don't have to do that. Depends where you are in the world of algebra. Whether you prefer to write those things at the moment to remind yourself what you're doing, or if you're comfortable. It's your business, that is. Okay. This diagram I've got here is trying to explain why we call it the balance method. We look at these scales here, and these scales here are representing 2n plus 3 equals n plus 6. So what I've done there is said, well look, n is a variable, n is I don't know, so I've got 2 n's plus 3 known things. I know the number 3 is a definite 3, it's not a variable, 3 is 3. So the analogy we've taken is that the n's are unknown weights, which we call these little black balls, so there's an n and there's an n, hence yes, I've drawn 2n there, plus 3 known weights, let's just call them kilos, that'll do, let's say all the weights are in kilos. So 2n plus 3, there's my 2n's, the unknown black balls, and plus 3 known weights. Well, they balance with, the equal sign says is equal to the same weight as n plus 6, so only one unknown, one n ball, and 6 kilos. So there's the picture of 2n's plus 3 equals n plus 6. Now, if we remove one of the variable weights and 3 of the 1 kilo weights on each side, the scales must still be balanced. What we're trying to do there is just get a single n equals something. So if I want n equals, well, I need to remove one of the n's. Well, that's okay if I remove that black ball and that black ball, must still be balanced. If I remove these 3 kilos and these 3 kilos, things must still be balanced. And what I end up with, a single n on the left balancing 3 kilos on the right. N equals 3. Yeah, that's exactly, hopefully a good analogy to see why doing the same thing to both sides is allowable. Algebraically, of course, we're not going to draw balances all the time. I would have written 2n plus 3 equals n plus 6. And I would have said, look, I want the answer down here to be n equals something. Okay? In other words, I want to get rid of all the other stuff. Now, note that if I've written it here on this page, note this thing here. And it says optional, but I always like to do it. It says collect the variables to whichever side of the equation already has the most. In other words, if I've got 2n on the left and only n on the right, it's like I'm saying the left has seniority, you know, respect the elders. 2n is bigger than n, so the 2n gets to sit there, and this n has to disappear. So the real truth is, if you want to collect your n's on the left or if you want to collect your n's on the right, it's your business, it doesn't really matter. Let's look at why I do it this way. I say wherever the most n's are, you can sit there. So I'm going to just move you. How do I remove an n? If an n is sitting there, If a rock is sitting there, what do? I subtract it. I take it away. If I want to move a rock, I take it away. If I want to remove an n, I'll take it away. So I'm going to take an n away from that side, and I've got to do the same to both sides. So the left was 2n plus 3, but I've taken an n away, so now it's only an n plus 3. On the right, it used to be an n plus 6, but I took the n away, so now it's just a plus 6. Now I look at my equation and say, well, that's cool. My n is nearly by itself, but I've got a plus 3 there. What's the opposite of plus 3? I'll take it away too. Minus 3. And so n plus 3 minus 3, well, that's just an n. And 6 minus 3, what's that sound for? Anyway, ignore it, David. 6 minus 3 is 3. There we go, I got my n equals 3 answer, which we knew. Now I said that this was optional. I could have dragged all my n's to the right if I wanted, but look what would have happened. If I'll just delete this stuff for a second. Yeah, very manual, isn't it? I'm sure there's a smarter way. If I said, no, I'm going to make the 2n move, well, I can. I could have taken that 2n away and taken a 2n away, and I would have left with, well, that's taken away, 3 equals n minus 2n is minus n plus 6. But why bring a minus n into it? I know I want my answer to be n. So I still could have finished that. I could have taken 6 off both sides. 3 minus 6 is a minus 3. Minus n plus 6. Well, the plus 6 is gone. Minus 3 equals minus n. And then I could say, well, how do I get rid of minus off both sides? I can times both sides by minus 1. Because a minus times a minus is a plus. So timesing by minus 1 will give me minus 3 times minus 1 is 3. Minus n times minus 1 is n. 3 equals n equals 3. So I got there, but wasn't it easier when I just let the big ones sit there and took the little ones away? The reason being, it always stays positive. So I stand by that rule. So what have we got here? Whatever you do to one side of the equation, you do to the other. Okay. We think in terms of opposites is what this statement's saying. So to remove a plus 3, I subtracted 3. Soon we'll look at examples where to get rid of a times 2 or divide by 2 and so on. To solve equations, the aim is to get the unknown by itself. Yes. End up with like x equals 7, n equals 3. The aim is to get the letter by itself equals something. I've already discussed clicking the variables to whichever side has the most. Remove numbers and terms by performing the opposite operation. That's what we've been doing. And perform the same operation to both sides. Okay, I'm repeating myself a bit here. Let's go to the next page. We've got an example. Solve 7x minus 4 equals 17. Now, it looks like we've done 2 options here. And you could say it doesn't matter. I've got a methodology, which I'll talk to you about. 7x minus 4 equals 17. Now, I want to get that x by itself. On the left, I can see there's a minus 4, and 7x means x times 7. So there's a times 7, and there's a minus 4 happening. So I know at some stage, to get rid of the times 7, I'm going to divide by 7. So I can see that in my future. And to get rid of minus 4, I know I'm going to plus 4. But the point is, between option 1 and option 2, which should I do first? Now the answer is it doesn't matter. You're still going to be right. It's not like an order of operations here where I say, no, I've got to do this first. Well, if I'm playing with scales, I can do a times thing to both sides, they're still equal. I can do a minus thing to both sides, or a plus thing, or a divide. It doesn't matter, as long as I'm doing the same thing. It's not the order that's a problem, it's just, are you doing the same thing? Are they still balanced? But I hope that you'll agree with me that, oh, look at that minus 4. It'd be pretty easy to just plus 4 to both sides. So always with equations, first thing I look at is wherever the most x's are, whichever side of the equation has the most x's, you can stay there. Well, there's only x's on the left here, so that's a no-brainer. I'm moving the x's to the left, or I'm keeping the x's on the left. The other stuff has to go. I'm going to go option 1. I can see it's easy to get rid of plus or minuses. I'm going to get rid of a minus 4 by plussing 4. So the minus 4 plus 4, well, they're cancelled. That's just 7x equals 17 plus 4 is 21. And now, to get rid of this, that's a times 7, I'm going to divide by 7. Now, I can write it this way. 7x divided by 7 means the 7 is gone. 21 divided by 7 is 3. Perfectly good way to do it, but note that a lot of people, including myself sometimes, will do this. That's not a bad way to go. if I want to divide this side by 7, instead of writing divide by 7, I might just write over 7 and over 7. Visually you can see that disappearing, and 21 on 7 is 3. So it didn't matter which way I wrote it. Yeah, but this is not a bad method of just writing over when I'm doing divide. Now, so that was option 1. Now look at option 2. If I'll just erase, Control A, delete. If I go back to the beginning and say 7x minus 4 equals 17, and someone said, but I wanted to get rid of the 7 first, well, you can if you want. I can divide this by 7, this by 7, and this by 7. Okay, note that everything's got to cop that divide by 7. So you can do it that way, and then, okay, that's cleaned up. But, I don't know, I don't like this method. So that's what I got. And now how do I get rid of a minus 4/7? Well, a plus 4/7. So x minus 4/7 plus 4/7 is just an x. And 17 on 7 plus 4/7, well, they're the same denominator, so that's a 21 on 7, just adding the tops, which is 3. Yeah, I got there, but look, I advise you, plus and minuses are so easy to get rid of. I focus on plus and minuses, then I do my times and divides. Okay, which is what this spiel talks about. One thing I should say is we can always check our answer by substituting back in, which I've got written down there. That, okay, I got an answer of x equals 3. Unless it's a particularly complicated answer or a nasty fraction, it's pretty quick to test that answer. Was x equals 3 right? Well, if that was a 3, that would then say 7 times 3 is 21, and 21 minus 4 is 17. Yeah, that's a pretty quick check. Okay, so just to be sure, it's nice to be able to check your answer. Okay, what have we got next? Another example, we've got 2x minus 9 equals 6x plus 3. Well, you can see here I've got more x's on the right than the left, and that's where I'm going to let them stay. That's the old man. Respect your elders. This little 2x can move. How do I get rid of a 2x? I subtract it. So I'm going to subtract that 2x away and subtract that 2x away. You can see my first focus is I make the decision about whether I'm going to the left or the right with the x's. Clearly I'm going to the right here. 2x minus 2x is gone. Don't forget that 9 owns that negative. It doesn't just become 9, it's still a minus 9. Equals, well, 6x minus 2x is down to 4x, and there's still a plus 3 there. Now, so I could if I wanted. There's a lot of people that don't like having x's on the right. If you want to stop here and say, look, if left equals right, you can just swap the sides if you want. You can swap them around and say, look, OCD, I want my x's on the left. I normally don't bother. I'm happy with the fact that I don't care which side it's on. What I'm going to do is say, I'm trying to get this down to x by itself. I said that getting rid of plus and minuses was easy. Let's get rid of this plus 3 by minusing 3, doing the exact opposite. Minus 9 minus 3, that's 9 steps back and 3 steps back, that's 12 steps back. 4x plus 3 minus 3 is just 4x. And now, how do I get rid of this times 4? Well, I'll divide by 4. And I'm going to go for that thing we said. I can just put over 4 if I want. 4x on 4, well, the 4's cancel, is just an x. A minus divided by plus is a minus, and 12 on 4 is 3. Minus 3 equals x. I've said here that it doesn't matter. I'm at the point in my life where I don't mind writing minus 3 equals x. I've solved the equation. But if there's a itchy sensation in your brain, which I used to have, that needed the x on the left, you can rewrite it. It doesn't matter. So there's some examples there which are all doing the same thing. 4x plus 3 equals minus 5. There was only x's on the left, so I went with it. Here, there's only x's on the left. Let's look at this one because it's a bit different. It was a 4x on 7 plus 2 equals minus 6. Now, I admit, like I've done there, my tactic is to get rid of the plus or minuses first, and so I would have taken 2 off both sides. So this that I've got here, I stand by. But a lot of people, and it's no big issue, actually, should that even be there yet? That example, it's a bit premature, because we do, yeah, okay, that's annoying. I'm going to get rid of that example, actually. So that's not going to be on your sheet when you look at it. Because we look at denominators in like two sections, so ignore me there. That's going to be replaced with something else magically. So I'm not going to do that right now. I will look at 7x equals 18 minus 2x and say, well, here, what's bigger, a 7x or a minus 2x? Well, definitely 7x, because 7 compared to minus 2 is much bigger. What if I had a question, I'll come back to that in a sec, what if I had a question that minus 5x equals 10 plus x? Where are more x's there? I've got minus 5 on the left and got 1 on the right. There's more x on the right, okay? Because 1 is bigger than minus 5. Okay, so just note the sign's important. Just because it says 5x, no, it's minus 5x. With this one, I said I'm leaving the 7x here. How do I get rid of minus 2x? Well, I'll plus 2x to both sides. 7x plus 2x is 9x, and that leaves the 18 by itself. And then to get the x by itself here, it's got to times 9, so I'll divide by 9, and that'll give me x equals 2. So hopefully these are really nice, and we'll move forward. Then it says equations with grouping symbols. So if there's brackets in the question, sometimes there's a choice, sometimes, well, there's always a choice of which way to go, but sometimes it's a clear choice of which way is easy and which way isn't. Let's look at this first one. 3 outside of a plus 7 equals 4 outside of a minus 2. Well, definitely here, I do want to expand those brackets. Okay, you could say, well, can I get rid of the 3 by dividing both sides by 3? Yeah, you could. But does it make life easier if that's a 4 on 3? No, I don't want fractions in here. Our main aim is when we've got fractions in there to get rid of them, not to bring them in. So no, definitely expand brackets, don't form fractions. Expand brackets, well, that 3 is only times in these two things, so it becomes a 3a plus 3 7 is 21. That 4 is multiplying these two things, so it becomes a 4a and minus an 8. Now there's more a's on the right than the left, so I'm going to let it sit there, and I'm going to take 3a away from both sides. Take 3 away, take 3a away. It's gone. All I've left with is 21 on the left. Here I've got 4a minus 3a. Well, that leaves me with just 1a. I don't have to write the 1. Not wrong if I do. A minus 8. I'll get rid of the minus 8 by plus an 8. Again, got to do it to both sides. 21 plus 8 is 29 equals a. I'm done. A is 29. Okay. Now, what about this next one? Okay, here's a good selection, David. This is better than the example on the last page. Can I expand the brackets? Absolutely I can, which is what I've done here. I could say 2x minus 8 equals 16, and then I could add 8 to both sides. And note again, me writing this plus 8 is just to help those that algebra is new to you. It's not part of essential working or anything. I was about to skip it then, but I thought, no, don't skip it. I'm just, so okay, this notation is just if it helps, purely optional. Minus 8 plus 8, it's gone, so it's 2x equals 26 plus 8 is a 24. And let's divide both sides by 2 to get x equals 12. Yeah, there's nothing wrong with that. But note that since I wasn't forming fractions, I could have divided both sides by that 2. I could have, instead of expanding, because I don't really want a 2x, I want an x, I could have just said it's easy to get rid of that 2 times. Because if all of that goes over 2 and all of that goes over 2, it's gone. Let's just Alt-Tab and we'll pause for a second. Sorry about that. Knock at the door. So where were we? We said yes, so it was easy to actually divide that 2 from both sides because 16 divided by 2 was 8. If it was a 3 here, I wouldn't do 3 divided by 2. I didn't want to bring in fractions, but if I can divide both sides by 2 and not form a fraction, then I'm pretty happy. 16 on 2 was 8, and then we'll plus that 4 to both sides, and we'll say x equals 12. So I'm still sticking by largely the first method. It always works. The second method sometimes works. Okay, but you can see you've got options and just look which looks easier. We've got any others here, so we've covered those two. This one down here, well, that's all very similar. Expand the brackets and go for it. Now equations with fractions. So we've got to revisit fractions a little bit here. And the overall concept is that we don't want fractions in the question. Look at this first one. We've got a y on 6 minus 1 equals 3. I know that I don't want that 6 there. So what I can do, normally here what I would do is, again, get rid of that minus 1 by plussing 1 both sides. If I added 1 to both sides there, I'll get a y on 6 equals 4. And then, to me, that's nicer. But I've gone with a certain technique over here that the course does. But here, let's just finish this question off. I've got y divided by 6. I want y by itself. What's the opposite of divide by 6? It's times by 6. So if I times the left by 6, it just gets rid of the divide by 6. And if I times the right by 6, I get y equals 24. So there's me. I'm pretty happy with that method. But for the sake of methodology, what we can do anytime we get a question with fractions is we can multiply throughout by that denominator. If there's only a single denominator, that's the one I'll use. If there's multiple denominators, I'll multiply throughout by the lowest common denominator. We'll get there in a sec. At the moment, the only denominator is 6, so let's times everything by 6. So I'm going to do a 6 times this, minus that times 6, and that times 6. Every term there got times by 6. Notice I only times the top of the fraction by 6 because, well, 6 is a 6 on 1. What happens if I times something, a fraction by 6? Well, only the top cops it, because it's a 6 on 1. So they cancel out. I get y minus 6 equals 18, and then I can add 6 to both sides to get rid of the minus 6, and I've got y equals 24. We're pretty quick either way. Okay, so there's example 1. Delete. Look at example 2. I don't have the same option here. If you look at that thing, what Dave said to get rid of plus or minuses, note that that minus 1 is trapped. I can't add 1 to both sides here because, remember, there's implied brackets on the top or bottom of any fraction that has to be done first. So I can't just nick a minus 1 out of there. If the minus 1 was here, great, but not if it's trapped up the top or under a square root sign or something. So the only real option I can do is, well, let's get rid of this divide by 5. It's a pretty clear option that I don't want these denominators here. I've got a denominator of 5. Let's times both sides by 5. Times by 5 times by 5. Now remember, don't put a 5 times, my next answer here isn't 5 times 3x minus 1. That times 5 just cancels the divide 5. So all I'm left with is the top. And the 7 times 5 is 35. Now I'm going back to my normal tactic. Get rid of plus or minuses, that's easy. Let's add a 6 to both sides to get, I don't know why I said 6. Let's add a 1 to both sides to counter the minus 1. That gives me 3x equals 36. And let's divide by 3 to get rid of this times by 3. 3x divided by 3 is just the x, and 36 divided by 3 is 12. Alright, more examples. Already got on the next page. We've got, alright, a 2x on 5 plus a 7x on 10. Now I've got it all written out here where I put brackets here, and again, very methodical. But in practice, let's just look at it. What's my lowest common denominator? Now if you want to use the denominator of 50, you could do that. 5 times 10 is 50, and I could times everything by 50. But the lowest common denominator was when we did fractions, we said, let's look to see if the biggest denominator will do the job. And in this case, it will. Is 10 a multiple of 5? You bet it is. The lowest common denominator here is really just 10. I might just change colour for a second. If I change colour to blue, so I'm going to times everything by 10. And again, I only do it to the top of fractions because it's a 10 on 1. Alright, now I'm going to go back to my red. Okay, now let's cancel some stuff. That 10 there cancels with that 10. Great. Perfect. I've got no denominator there anymore. Same thing happens here. I've got a 10 up there and a 5 here. So that's 2 5s in U and 1 5 in U. So that just made everything a lot easier. Now it just says 2 times 2x, which is 4x, plus I've just got a 7x, equals 1 times 10 is 10. 4x plus 7x, well, we know that's 11x equals 10. And let's get rid of that 11 by dividing both sides by 11. In other words, x equals 10 on 11. What if I had times everything by 50? Well, that still would have worked. My initial line of 2x on 5 plus 7x on 10 equals 1. Yeah, I could have times by 50 there, I could have times by 50 there. And yes, I could have cancelled. I've got 1 10 there and 5 10s there. I've got 1 5 there and 10 5s there. And that's 10 times 2x, that's 20x, plus 5 times 7x is 35x, equals 50. And then I would have said 20 plus 35, 20x plus 35x is 55x, equals 50. Hence x equals 50 divided by 55. Notice the only difference was it's not simplified. Using the lowest common denominator, I dealt with smaller numbers and it was simplified. Not always, but it was in this case. But it's always simpler. 50 on 55, well, how many 5s in u? There's 10. And how many 5s in 55? There's 11. I've still got the same answer, but the lowest common denominator is great if we can go that way. Let's look at the next example. Down here we've got an x on 3 plus an x plus 1 on 5 equals 5. First thing I like to do here is what I've said here, bracket any numerators or denominators with a plus or minus. In other words, I don't want to bracket that x, that doesn't do anything. But I just want to make sure if I do anything to this numerator, like if I want to times this numerator by 3, it doesn't become 3x plus 1, it's 3x plus 3. Everything should get times. So that numerator, if it's going to have something happen to it, should happen to the whole thing. So I deliberately put brackets there. My lowest common denominator here, between a 3 and a 5, there's nothing better than a 15. So I'm going to do a 15 there, a 15 times there, and a 15 times there. Now, as always, I'm going to cancel any common factors. And a 15 on 3, well, I've got 1 3 there and 5 3s there. A 15 on 5, I've got 1 5 there and 3 5s there. And again, this always happens. It gets rid of my denominators. Now I've just got a 5x plus a 3 outside of x plus 1 equals 5 by 15 is 75. Now let's expand those brackets so we can collect some like terms. Remember, it's 3x plus 3. The 5x plus 3x is just an 8x. And how do I get rid of a plus 3? A minus 3. How do I get rid of a times 8? I divide by 8. X equals 9. Maybe you consider them to be fun. I do. It might be an illness. Last one, is it? Let me just check. Yep, okay. I put in quite a few examples too. I hope you consider it quite a few. And some extra ones on Blackboard. Okay, we've got an x on 4 minus x minus 2 on 3. Really it's the same as the last one, but just with one minor trap. I'm still going to bracket any numerators or denominators that have operations in there, plus or minus. My lowest common denominator is 12. Oh, I won't change colour this time. We can handle that it's the same colour. There's a 12, there's a 12, and there's a times 12. 12 on a 4, well there's 1 4 there and 3 4s there. 12 on a 3, well that's 1 3 there and 4 3s there. And so I get 3x minus a 4 out the front of the x minus 2 equals minus 1 by 12, which is minus 12. Let's expand the brackets, and the trap I was talking about was just this thing, which hopefully isn't that bad. A minus 4 times an x is minus 4x. Then a minus 4 times a minus 2, it's got to go plus 8. A 4x minus 3x, well that's negative x. Let's get rid of this plus 8 by minusing 8. Minus 12 minus 8, it's all backwards, minus 20. And we came across this once before where I've got a minus that in front of the x that I don't want. So I'm going to times it by minus 1. And a minus times a minus turns plus. So minus x times minus 1 is an x. Minus 20 times minus 1 comes plus 20. And we're done. Okay, I hope that didn't look too bad. Have a go at the exercises and see what you think. Okay, see you later.